In this video series, we will discuss all the topics outlined in the Juniper exam objectives for the JNCIS SEC exam number JN0-332. In this course, we will cover an overview of Junos security. We will have some Q&A as well as short quizzes at the end of each section to test your knowledge. At the end of the course, we will provide you with a practice test to help you gauge your readiness for the exam. So without any further ado, let's begin our journey into the Junos security. In this chapter, we will cover an intro into Junos security. So let's begin at Layer 3. Routers are Layer 3 or IP address-based systems that forward packets. They are stateless, which means they do not keep track of the state of a session. And routers separate broadcast domains. They provide routing which is needed for connectivity outside of a VLAN, and Layer 2 switches do not. Traditionally, a router forwards packets based on a Layer 3 IP address. They use some type of path determination. Packet processing is stateless and promiscuous. Routers separate broadcast domains and provide WAN connectivity. Routing tables are built from dynamic routing protocols, static routes, or both. Routers alone do not provide enough security. This job is usually taken by a traditional firewall, which processes packets statefully, performs NAT, and establishes VPNs. Firewalls also can provide additional services such as IDP, or intrusion detection and prevention. Layer 3 packet forwarding. A traditional router is a promiscuous device that performs stateless packet processing. It is promiscuous because once it is configured, it immediately forwards all traffic by default, provided of course that some combination of static and dynamic routing is configured. Typically, a router operates only at Layer 3 and does not recognize any security threats in high-layer protocols. Furthermore, a traditional router operates per packet, which adds to its fundamental insecure nature, because it cannot detect malformed sessions. The network and the router itself are immediately vulnerable to all security threats. Firewalls process packets statefully, keeping track of source and destination IP, source and destination port, protocol, and session token, which is derived from a routing instance and a zone. Devices at the edge of a network must be able to replace non-routable addresses with public addresses and vice versa. Enterprise customer premises applications are served by the J-Series family of service routers, and in the case of larger enterprises, M-Series routers are used. Enterprise data center applications can also be serviced by M-Series routers. Firewalls can build VPNs to allow secure transit between private networks across the Internet. To do this, it must authenticate the other endpoint, encrypt traffic to the other endpoint, and encapsulate it so that it can cross the Internet. Compared to routers, firewalls do not let any traffic pass by default. You have to configure it to allow it. Routers allow all traffic by default. Junos security platforms combine the features of routers with the security of firewalls. They use Junos OS processing of routing, management, and others. Packet forwarding is packet-based, or every packet is fully inspected, but Junos security platforms add flow-based forwarding, where each packet flow is inspected, as well as policy and additional inspection, including ALGs and IDP, or intrusion detection and prevention. Junos security devices are logically divided into control plane and a data plane. The control plane is handled by a routing engine, which handles the chassis management, user interface, and routing protocol tasks. The data plane handles packets in a session-based format.